Hi friends, very good morning. In this video, I just want to create, I just want to show some insight on what is a point charge. Because when we see our electrostatics, even in the electrostatics, we started with Coulomb's law. Coulomb's law basically gives us the force between any two point charges. And we started by knowing the electric field intensity due to a point charge. After knowing this, we extended our discussion, we extended this concept to the electric field intensity due to the remaining charge distributions. So that is the reason why understanding the point charge is very important. Hence, in this video, I will just provide an insight into the point charge. So it will be a very interesting video, right? So first we will see what is a point. What is a point? See, a point can be defined only by its location. Is it right or not? So a point in a space has some coordinates, whether it may be two-dimensional system with xy coordinates, whether it may be three-dimensional system with xyz coordinates. So whatever it may be, so the point has some coordinates. What are these coordinates gives us? These coordinates gives us the position of that point or the location of that point. So point can be defined only by its location. It is a very important thing which we need to keep in our mind. And the second most important thing is that it cannot be defined by its dimensions. Dimensions means physical dimensions. What are the physical dimensions we have? So we have the length, we have an area, we have a volume. These are some physical dimensions of any object. So what we need to understand from point is we can define a point only by its location but not by its area, length, volume, because for specifically a point, all these are zero. They are very negligible, means they are neglected, almost zero. Now I am extending the same concept to a point charge. Now how can I define a point charge? So now if you observe a point charge, again a point charge can be defined only by its location and charge, magnitude of the charge. Okay, so a point charge, now we can understand the point charge as a entity which can be defined only by using its position as well as its charge. The second important thing which we need to understand about a point charge, the same thing, it cannot be, okay, so it cannot be defined by its dimensions, length, area and volume. All are for these point charges are zero. Okay, now what we need to understand is whether these point charges exist or not. What is the answer for this question? Whether the point charges exist or not. So actually there are no point charges. Practically speaking, there are no point charges, but we can consider some of the charges as point charges, right, by taking into consideration the properties of point charge. What are the properties of point charge? First property is it must be defined by its location and charge, it cannot be defined by its dimensions. So means it indicates that either the length or area or volume, these must be a very negligible values, or you can sometimes consider its mass also, right? Now we can say that practically there are no point charges, but we can consider some of them as point charges, some charges as point charges, in which cases, see, so they exist now. My answer is exist. How? See, we have an electron inside an atom, right? Okay, and we have a proton. So we know that the electron has negative charge and proton have positive charge. Now if you observe, what is the weight of the electron? It is 9.31 times 10 power minus 31 kg. Similarly, what is the weight of proton? It is 1.67 into 10 power minus 27 kg. Now, seeing these figures, understand? Seeing these figures, can you say that these are the considerable weights or not? We cannot consider them as weights, because see, 10 power minus 31 kg means 0.0000 like that up to 30 kgs. So it is a very lesser weight. So its dimensions can be negligible, but we can define them by their locations. Hence, we can consider the electron as well as the proton as point charges. This is one way of understanding the point charge, the existence of point charge. So somewhere here, in my intermediate, somewhere in some textbook, I read that when we assume, okay, because the science is basically a byproduct of imagination, because the imagination plus some mathematical base will make it as a fact. Okay, so in our intermediate textbook somewhere I read that if the weight means if an electron is assumed to be a ball, is assumed to be a cricket ball, then the atom size will be equal to Lal Bahadur Stadium. See, if the electron size is assumed like a ball, the atom size will be Lal Bahadur Stadium. See, the size of Lal Bahadur Stadium is very much higher when compared to the size of the ball, right? So when we compare these two sizes, the ball seem like a point charge, means a point object. So here, in order to consider the electron and proton as point charges, the very base that we are considering is the point charge must be defined by its location and charge. It cannot be defined by its dimensions. Okay, so you all know what is the charge of an electron. It is I think it is 1.6 into 10 power minus 19 coulombs. Okay, so this is the charge of electron with a negative sign, and you know the charge of proton. Okay, so this is the first way of understanding the point charge. So point charges practically do not exist, but we can consider the electron and protons as the point charges because they have very lesser dimensions, means their size is very lesser. Okay, and they can be defined only by its location and charge, but not by its dimensions. Okay, and the second way of understanding the point charge, we have consider another example. Okay, which is a very another interesting example. I have two spheres, means this is one charged sphere and this is another charged sphere. Let us consider both are of equal size. Okay, so let us consider the charged sphere has, this charged sphere has the charge of q1 and this charged sphere has the charge of q2. Okay, so this is a sphere 1 and this is sphere 2, charged sphere. Now if you consider the distance between these two spheres is very lesser, right? So let us assume that the distance between these two spheres is very much lesser when compared to size of the spheres. Okay, I am considering both the spheres are of equal size, and this is the case. Now I just separate them a little bit like this. Now you have the sphere, here you have another sphere. So this is q1 and this is q2. Now if you observe the distance, this is the distance. So the distance is comparable to size of the spheres, right? Now again I am increasing the distance between the spheres. So first sphere here and the second sphere here. Now if you observe, the distance here is greater than the size of the sphere. If I increase the distance far from this, means I consider one charged sphere at one side of a cricket stadium and another charged sphere at the opposite side of the cricket stadium. Now if you observe, what is the distance between them? It is a very high when compared to the size of the spheres. Okay, I am taking an example. If the distance between these two spheres is very much higher when compared to the sizes of the sphere, then also we can consider them as point charges, right? See, when the distance of these two spheres is very much higher, by seeing from this sphere looks like a point, and from this sphere, if you look at this sphere, it looks like a point. So when the distance between the two charged objects, not only of regular shape, it may be of any shape, okay? So when the sizes, means when the distance between the two charged objects is very much greater when compared to the sizes of the charged bodies, then we can consider such charged bodies as point charges. Okay, so this is one more way of understanding what is meant by a point charge, because point charge has a very crucial role in electrostatics. We start our electrostatics with Coulomb's law, which gives us the force between point charges and electric field intensity due to a point charge. So point charge forms the basis. If you don't understand what is meant by a point charge and whether the point charge exists or not, or in which cases we can consider the charges as point charges, if we cannot understand this, then it is no use if you even make some hundreds of problems on Coulomb's law. Okay, so that's why in this video I have decided to give the insight on point charge. Okay, so thank you very much for listening to this video.